we want to find the inverse Laplace transform of big F of s in order to find the function f of t. So beginning with the given function big F of s equals 2s divided by the quantity s squared plus 16 plus 5 divided by the quantity s squared plus 16, we'll take the inverse Laplace transform of both sides of the equation, which will give us the inverse Laplace transform of big F of s equals the inverse Laplace transform of 2s divided by the quantity s squared plus 16 plus the inverse Laplace transform of 5 divided by the quantity s squared plus 16. Now looking at our table of Laplace transforms, because we're given the function big F of s and we're trying to find the function f of t, we'll be using the table in this direction here. So on the left side of our equation, the inverse Laplace transform of big F of s is equal to f of t, which is what we're looking for. So we have f of t equals, now we need to figure out which formula to use to find the inverse Laplace transforms on the right side. Notice how both the denominators are the quantity s squared plus 16, and here we have a numerator of 2s, and here we have a numerator of 5. So we'll be using these two rows in order to determine the inverse Laplace transforms. Notice how here we have a numerator of s, and here we have a numerator of a, which is a constant. So let's rewrite the right side as 2 times the inverse Laplace transform of s divided by the quantity s squared plus 16 plus 5 times the inverse Laplace transform of 1 divided by the quantity s squared plus 16. So now looking at this inverse Laplace transform, notice how it fits this form perfectly. The numerator is s, and the denominator is s squared plus a squared, where a squared is equal to 16, meaning a equals 4. But now looking at this inverse Laplace transform, again we know that s squared plus a squared is equal to s squared plus 16, so because a equals 4, the numerator must be 4 as well, and right now it's 1. So let's rewrite 1 as the fraction 4 over 4. And now what we can do here is factor out 1/4, so we just have 4 in the numerator. So let's rewrite this one more time. We have f of t equals 2 times the inverse Laplace transform of s divided by the quantity s squared. Let's write 16 as plus 4 squared, so it fits the form perfectly. And now here we're going to factor out 1/4, so we'll have plus 5/4 times the inverse Laplace transform of, factor out 1/4, we're left with 4 divided by the quantity s squared. Again, let's write 16 as 4 squared. So again, notice how both inverse Laplace transforms now fit these forms perfectly, where in both cases a equals 4. Which means f of t is equal to 2 times this inverse Laplace transform, which again, because a is equal to 4, is equal to cosine 4t. Then we have plus 5/4. This inverse Laplace transform is in this form where a equals 4, so the inverse Laplace transform is sine 4t. So we have 5/4 sine 4t. So by using inverse Laplace transforms, we're able to find the function f of t, which is what we enter here. 2 times cosine 4t plus 5/4 times sine 4t. I hope you found this helpful.